Now we're going to talk about viscosity. All fluids have viscosity. Viscosity is the resistance of a fluid to flow. The more the resistance, the higher the viscosity. Think of walking through water. As you walk through water, the water puts a force on you and prevents you from walking through it. But now, think about walking through honey. It's even more difficult. Honey is much more viscous than water is, and it's much more difficult to walk through honey than it is to walk through water. Honey has a much higher viscosity. Viscosity always involves the resistance of the fluid to flow. It's a measure of how much resistance the fluid has to the flow. The fluid puts a force or a stress that prevents the flow. The stress is the viscosity times the rate of flow, or the rate at which the fluid flows over itself, the strain rate of the fluid. Here's the formula for the viscosity. The units are stress times time, or Pascal seconds. There are many examples that we were told about by Nathan Myhrvold. He explained why viscosity is very important, and there are many culinary examples. The simplest, of course, is water, which flows much more easily than oil. Water is much less viscous than oil. But oil has a viscosity that changes very strongly with temperature. If you increase the temperature, the viscosity of oil decreases quite substantially. In fact, if you heat it up enough, it can become as low viscosity as is water. Many fluids have a very strongly temperature-dependent viscosity, and we use that in cooking very often. To understand viscosity from a more molecular view, let's look at this little cartoon. The fluid is made up of many, many molecules, and the molecules are constantly moving around. But in order to cause the fluid to flow like this, we have to cause the molecules to move over one another. In fact, for the fluid to actually flow, the molecules have to exchange places with each other. And so the viscosity depends on how fast they change places with each other. So the viscosity is given by the density times the speed of the molecules times their size. It's just a measure of how fast the molecules move over one another. And you can see immediately that larger molecules take longer because they have a longer way to go to move over one another. In fact, the speeds of the molecules are almost independent of the different kinds of fluids. What changes most is the size of the molecules. We can make an estimate of what the viscosity is. The speeds of molecules are always about the same. They're typically about 1.5 to 2 kilometers per second. That's the speed that the molecules move past one another. The densities of fluids are also quite similar. They're about 10,000 kilograms per cubic meter, 10 to the 4 kilograms per cubic meter. So we can easily estimate what the viscosity is of water. We just take the density times the speed times the size of a water molecule. And for the size of a water molecule, I'll take 3 angstroms, or 3 times 10 to the minus 10 meters. If I use these, I get a value of 4 times 10 to the minus 3 Pascal seconds, or 4 millipascal seconds. In fact, this is very close to the value that you measure for water. The measured value of viscosity for water is about 1 millipascal second, or 1 times 10 to the minus 3 Pascal seconds.